Alright, in this video we're going to be writing the static method isLatin, which returns true if the following conditions are true for a two-dimensional square array. The first row has no duplicate values, all values in the first row of the square appear in each row of the square, and all values in the first row of the square appear in each column of the square. And we're also given these two helper methods, containsDuplicates and hasAllValues, where containsDuplicates returns true if an array that's passed in contains any duplicate values, false otherwise, and hasAllValues returns true if every value in the first array also appears in the second array. So let's go ahead and write out some pseudocode. We're given these three conditions that have to be true for this to be a Latin square. So let's go ahead and check that first condition. Check that the first row has no duplicate values. Okay. Next, what we want to do is we want to make sure all values in the first row of the square appear in each row of the square. So loop over all rows in the square after the first row. Check that all the values in the first row of the square appear in each row of the square. Okay. That's our second condition. Now we have that final condition, which is making sure that all values in the first row of the square appear in each column of the square. So loop over all columns in the square. Check that all values in the first row of the square appear in each column of the square. And if we have gotten to this point, we can confirm that our two-dimensional array has checked off all three of those conditions. So in this case, we can return true. We have found a Latin square. That's our pseudocode. Let's go ahead and jump into the actual code. So checking that the first row has no duplicate values, let's see if we have any helper methods that might help us with this. So remember, we have this containsDuplicates method. So this will be returning true if it contains duplicates, false otherwise. So the first row, how do we grab the first row? Remember that two-dimensional arrays are row major. So to grab the first row, that would be grabbing square at 0. And we want to check whether that contains any duplicates. So we're going to pass that in as a parameter into the containsDuplicates method. If it contains duplicates, then that means that this is not a Latin square. So in that case, we're actually going to return false. So the condition is that the first row has no duplicate values. So we're kind of returning early if we have found duplicates within that first row. Next, we want to loop over all rows in the square after the first row. So for our conditions, normally, we start off at I = 0. But in this case, remember, we're checking that all values in the first row of the square appear in each row of the square. Well, we don't really need to check the first row because that's what we're comparing it to. So we can actually have this start at 1, and then we can say we want to keep going until square.length, where square.length is the number of rows within our two-dimensional array, and then we want to look at every single one of those rows. So we want to check that all the values in the first row of the square appear in each row of the square. So this is where we might want to see if we have any helper methods that might help out with that as well. So it looks like we have this hasAllValues method. We pass in two arrays and we check that those have the same values. So we want to once again check if hasAllValues. So we're comparing it to the first row of the square, so that would be square at 0. And then we're using our I to loop over all the rows. So at any point in time, we're going to be looking at some other row within the square that's not the first row, which we're going to grab using square at I. Okay, but then, see, the thing is, if it does have all the values, then that means that that satisfies that condition. So we actually want to negate this to say that if some row in the square does not contain all the values in the first row of the square, then we also want to return early and return false. Next, we want to loop through all the columns in the square. So another for loop for int I = 0. So here we're starting at 0 because we're comparing it to the first row in our square, not the first column. So we do actually need to go through every single column within our square. So we start at I = 0, I is less than, so now we actually want to go through the number of columns in our square. So you can get that by just getting the first row and then saying the length of that row. So that gives us how many values are within that array, which also corresponds to the number of columns within our two-dimensional array. Then once again, we want to go through every single one of those columns. So now we're checking if all the values in the first row of the square appear in each column of the square. So once again, we're going to be calling our hasAllValues method. So hasAllValues. We're passing in the first row in our two-dimensional array, because once again, we're comparing each column to that row. Next, we want to get the column at that index. So you might remember in part A, we actually implemented a method called getColumn, where we're passing in some two-dimensional array and then a column index, and it spits back the column, basically, as a one-dimensional array. So we actually need to use that within our isLatin method. So getColumn. We pass in the two-dimensional array. So in that case, that would just be that two-dimensional array we were given into our isLatin method, square. And then since we're using I to keep track of the column index, we can also use that within our getColumn method. So what that's going to do is it's going to give us the column at index I within square. Once again, we want to negate it, because for a Latin square, that condition is true. So if we negate it, we're trying to find cases in which the two-dimensional array does not have all values in the first row of the square appear in each column of the square, and we want to return early, so we're returning false. Once we get to this point, we've checked all three of our conditions. So at this point, we can actually return true because we have found a Latin square. So that about sums it up for our code. So let's go ahead and use the first example of a Latin square that we have to make sure that our code works. And then we can go through an example where it's not a Latin square. So this first one, we've got 1, 2, 3 dispersed within our two-dimensional array. So we want to check whether the first row has any duplicates. So we kind of just have to do this by I because we don't have the implementation for containsDuplicates. So just by I can see that doesn't contain any duplicates, so we wouldn't be returning false. So we actually have passed the first condition. Next, we want to loop through all rows after the first row. So we would start off at I equals 1 and say that's less than square.length, which is 3. Now we want to check whether the row at index I contains all the values within the first row. So that would be comparing 1, 2, 3 to 2, 3, 1. Once again, we don't have the implementation that has all values, but if we just look at this by I, here's a 1, there's a 1, here's a 2, there's a 2, here's a 3, there's a 3. So for this row, we can say that it passes that. We move on to the next row. So that would be the row that contains 3, 1, 2. We can once again sort of spot check it and say, okay, it contains all the values within the first row. Then we try to increment our I again. Now 3 is not less than 3, so we have successfully passed the second condition as well. Next, we need to look at every column within the square. So we start off at I equals 0, which is less than 3. We need to compare that to the column. So we're comparing 1, 2, 3. We're comparing that to the column at index 0. So that would be 1, 2, 3. That contains all the values that the first row has. We move on to the next column, which is 2, 3, 1. Once again, all the numbers match up. They all contain the values within the first row. Next column, that would be 3, 1, 2. Once again, spot check, looks good. We try to increment our I again. Now this isn't true, so we have passed the third condition as well. So now at this point we can return true because we have found a Latin square. So now let's go through some examples where they are not Latin squares. So this first one that's being passed in, we're going to check whether the first row contains any duplicate values. So we grab that first row, we say that it has the values 1, 2, 1. Unfortunately, 1 shows up twice within this first row, so this is not a Latin square. It fails that first condition. So moving on to the next square, we check whether the first row contains any duplicates. 1, 2, 3. This one doesn't contain any duplicates, so we move on to the second condition. So we start off at I equals 1, make sure that 1 is less than 3. We check that all the values in the first row of the square appear in every other row, so 1, 2, 3, and we grab the row at index 1, so that would be 3, 1, 2. So this passes for this row. We move on to the next row. So that is 7, 8, 9. Unfortunately, this row does not actually contain any of the values within the first row, so we would return false here. This is not a Latin square because it has failed the second condition. Moving on to the last example, we have 1, 2 as our first row. This doesn't contain any duplicates, so it passes that first condition. We move on to the next condition. We set I equal to 1. 1 is less than 2. We check whether all the values in the row at index 1 contain all the values within the first row. So that would be, does 1, 2, that 1, 2 again. So that is true. That passes. We try to increment our I again. This is no longer true. So now we have passed our second condition. We move on to the third condition. So we set our I equal to 0. We grab the value at the array at the first row. We check whether each column within our square contains all those values. So our first column is 1, 1. Unfortunately, we do not contain a 2 within this column, so we would return false for this square. This is not a Latin square. If we get rid of all the pseudocode, here is what our isLatin method looks like, where we're checking whether the first row has no duplicate values, and then we're checking whether all values in the first row of the square appear in every other row of the square, and then we're checking whether all values in the first row of the square appear in every column of the square. And if at any case we fail one of these conditions, we return false early because there's no use to check the other conditions because it will not be a Latin square. If we've passed all 3 of those conditions, then we return true. We have found a Latin square. So hopefully this helps you with this isLatin method. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.